sometimes all the males get it, and sometimes all the females get it. What's so weird? I'm like, but why though? Why would that be?
Aloha, top of the morning, friends and family. On this channel, we upload one beautifully edited cinematic masterpiece per week, sometimes. And this video, however, is uncut. And in today's uncut video, it's actually cut, so there's that too. But Clint from Clint's Reptiles gave me permission to film his talk that he gave at the Denver Reptile Show. And there's lots of people that went. Don't be sorry. It's just an uncut video. It's no problem. So if you missed his talk, it was really interesting and really also funny, as Clint is many of the times. And so I'm going to give it all to you here, virtually uncut, minus switching back and forth between cameras. And before we do that, tomorrow, I'm going to have a Palmstreet Live, and I'll be with my buddy Riley, and we're going to be driving to the Phoenix, to Scottsdale for Reptile Show. So I hope to see you out there. But otherwise, enjoy what it is that Clint has to offer.
Okay, so this is my question. Why is genetics so boring? Well, it shouldn't be. I agree with you. But I've had a lot of classes about it, and it was consistently lame. I don't know. I'll tell you a thing about my education. I have gone to a lot of school, and I have hated school from the beginning. I would tell my parents every day in kindergarten about the heinous ways that my kindergarten teacher was butchering children in the hope that that would put an end to me having to go to school. I can remember when my dad was talking to me about high school dropouts. And I was like, okay, I got to get to high school and then I can drop out. Like apparently that's, like there was no talk of middle school dropouts because I would have for sure. Like that was actually the low point in the whole educational career was middle school. And I was like, high school dropout, I can make it that far. I went to Monarch High School, by the way, which is right here locally. But anyway, hated that. But then I've actually, middle school was the low point. I've liked kind of all of it a little better for the most part since then. Still hated it all though, but less and less. My undergraduate degree was from Colorado State, and I studied zoology, and then during my senior year, I added a major in biology because I found out if I took developmental biology instead of an elective, I would double major, and so I was like, all right, I can do that. And so I double majored, but biology was just like a happy coincidence that I'd taken just the right classes. Zoology was my degree, and during 4 years of zoology, I saw one live animal in the classroom, and it was hibernating. Somehow they managed to take the thing that I am the most excited about. Like literally, I did 4 years of zoology and didn't meet anybody who likes animals as much as I do. Like, you know, and so that, like I'm so into this. This is like my earliest memories that are like clear memories. I'm watching nature documentaries. That's what I wanted to do, right? I grew up with a subscription to zoo books because none of my friends liked animals. None of them. I had one friend who liked frogs. And then my next reptile friend, my first ever reptile friend, I met when I was 26. He grew up, interestingly, in Broomfield. I met him at BYU. Anyway, just like that. So crazy stuff. But they sucked all the fun out of something that I would go home and study for fun all the time. My entire life had been doing that, and they made that miserable, which I think is a skill. I don't know how you can do that. And one thing that I have discovered is that most of my education was learning the answers to questions that nobody was asking. Okay, and that's no good. That's no good. You don't even know what the question is you're learning the answer to. You're just like, well, here's more stuff I have to memorize. But I want to show you something. So I find it amazing. And this is why we've got a facility called Clint's Reptile Room. We go to schools, we have people come in, our YouTube channel. Like once you show somebody something real, a real animal, they suddenly want to know everything about it. And if you show them the right animal, they will want to know the answers to the very questions you were hoping to tell them anyway. I will tell you an animal that was pretty revolutionary for me, this one. I'm going to pull it out so you can see it. Can you guys hear me when I just talk with my regular voice? Yeah. Okay, I might try that unless my voice starts to fail. Okay. Because I'm all tied up. So, this snake, not this individual. I actually know none of these snakes. Like I have been bitten by, and this amazes people because I interact with a lot of snakes. I have never been bitten by a wild snake in my life. I've been bitten by 6 snakes. Only 2 I was looking at. Okay? All the others I'm interacting with a class or a person or a camera, and I'm not paying attention to the snake's body language. So like now I got like a flock of snakes I don't know. And I'm gonna get them out and I'm gonna look at you. Okay. So like I may be bitten by as many snakes as I've been bitten by in my life during this presentation. That's the thing that could happen. But this snake is a ball python. But I think it's pretty obviously unusual. And it's unusual in a spectacular way. This isn't, there are a lot of ball pythons that if you really know ball pythons, you're like, that's an amazing ball python. But somebody could know no things about ball pythons, right? And they see this ball python and they're like, wow, what is going on with this snake? Hi there. And I will tell you, so when I first found out about this snake, these cost about $1,000. And I was living on $12,000 a year as a graduate student. So I was like, boy, that is not going to happen. Technically, I was paid $16,000, but then I had to pay $4,000 back to the very institution that gave me the $16,000 in tuition. Net, $12,000 a year. You're not buying a $1,000 snake anytime soon. But I was like, wow, I want that. I want that in my life. And I couldn't afford it. Have still never bought one. Can't afford one. Have lots of them. Because I knew what the ingredients were. And the ingredients were things that I could afford. Now, I will tell you though, as I'm researching the ingredients, I'm learning some stuff that I knew for sure was wrong. And but I didn't know enough about the subject to know exactly what was right either. I knew what I was being told was wrong. So I'll tell you what I was told. So there's a snake over here. It's the ingredients. Can you go back in there for a sec? It's really fun on a light-colored snake like that. You can really see the legs very clearly, which is pretty astounding to people when they see. They start asking questions. Like, why does it have legs, though? Which is a great question. And then they're like, I thought it was a snake. And you're like, oh, it is a snake. What? But it has legs. Oh, I have worse news. There are lots of lizards that don't have legs, that aren't snakes. Sorry. But anyway, this is the ingredients for that snake. And actually, so my request was for a lesser. I think this is a Mojave. Anybody know better than me? Is this Mojave? looks a little dark for a lesser, and it doesn't have any of the dog bones. Doesn't matter though, they're both ingredients for that snake. They're different versions, different what are called alleles. Alleles are like different versions of the same gene. Okay, and they're different versions, but they're so similar to each other that if I breed two of these together, what I actually get is a snake like that, but with a gray head. But pretend like this is the lesser. The lesser's lighter than this, though, and that's kind of significant to what I wanted to talk about. So you're going to have to use your imagination just a tiny bit. Let's see. You got to stop going to sleep. I got too many things to juggle since this doesn't want to go backwards. But when I was researching this, I'm like, okay, so what I was learning over and over, so this is not exactly what a ball python typically looks like. A ball python, and you guys probably know this, it typically looks, this one's in shed. I've got another one though, if you want to see. So they're normally darker than this. This one should be lighter, this one should be darker. It's ruining the whole effect. But this is a ball python. This is what they normally look like. They often call this one a normal. I would refer to it more accurately as like a wild type, but normal's fine. I have two of them at the reptile room. Their names are Norm and Norma. That's what they look like, okay? This is a Mojave. It works the same way as lesser, and I'm going to go back to lesser. So what I would read about either of these is that these are dominant to the wild type, which, you know, I know what that means. I've known what that means for a long time. It's not up here, but, you know, like I learned about cartoon mice and cartoon flowers. I know all about genetics. That, for the record, was my entire education on genetics. Cartoon mice, cartoon flowers. For any of you who've had a genetics education, it's black and white mice. And what colored flowers?
Purple and pink and white.
Yeah, well, yeah. White and red, sometimes making pink, sometimes, yeah. That's it. That's my entire genetics education. It was quite lame. I had a whole class called genetics. I don't think we got deeper than that. Anyway, so this is dominant. Great. And, you know, it manifests itself if you breed it with those. Half of them come out looking like this and half like that, which is the same thing that you would expect if you bred something dominant. So I'm like, oh yeah, everything checks out. But then, if you breed these with one of these again, you get a quarter of those, half these, and a quarter of this. And they call this a super dominant. And then they tell me that this is codom, short for codominant, which is a thing, but this is not that thing. And so I was like, what? I mean, like I had no idea what was going on here. I knew super dominant is not a thing. That's not a thing. And I don't know how an allele can be codominant with itself. And you might not know what codominance is just yet. I'll explain that here in a second. But it was like that made zero sense. So let's talk about what codominance is for a sec. Yeah, super dominant, not a thing. This does so. Okay. Here's what it looks like. Here's what I knew from my drawings of mice. If I take black mouse and I breed it with a white mouse, and all of the babies are black, then black was dominant to white. White was recessive. If I breed a black mouse and a white mouse and all the babies are white, that shows me that white is actually the dominant allele there. And what's happening here is you've got what are called heterozygotes. Have any of you ever heard this word before? So I told you before, alleles are like different versions of the same gene. Okay. Well, you actually have two copies of every gene you have, unless you're a guy. You have two copies of every gene you have. You got one of them from your mom and one from your dad. And this is almost true for guys too. I'll explain why not here in a minute. But, and so sometimes the version that you got from your mom and the version you got from your dad, they're the same. All right? Like if both of your parents were black mice, you're probably going to get the black allele and the black allele from both, and you're probably going to be a black mouse. And that's called homozygous. However, if the version that you got from your mom is different than the version you got from your dad, then they're different, and that's heterozygous. Dominant, recessive, incomplete, dominant, codominant, all these words we've been saying, these only matter in heterozygotes. Homozygotes always look like whatever allele it is that they've got two of. Okay? So there's nothing special. In a homozygote, nothing weird happens ever. It's always exactly what you can do. I'll tell you here, this isn't in my notes, but want to talk about inbreeding for a second? Okay. I actually, if you guys watch our videos, I make quite a few of them responding to young Earth creationist arguments. And so there's a guy, his name is Kent Hovind. He's kind of, even most of the creationists are like, don't listen to that, don't listen to him. But anyway, he comes up a lot in my feed anymore because I spend time looking for videos to react to. And today I was listening to him talk about how polydactyly is caused by inbreeding. Okay, and I'll just tell you, inbreeding causes no mutations. All right, at the point when mutations happen, those future gametes, which are like sperm and eggs, they've got no idea if they're going to fuse to the gamete of a close relative someday. It has no effect on if they're going to produce mutant versions of the gametes or not. They've got no idea. And the moment that they fuse, they're like, wait, aren't you my, let's mutate. That doesn't happen either, right? Like there's nothing like that. It's just that in everybody's genome, you've got some recessive alleles that are pretty weird. There's not a big deal because you're a heterozygote for all those things. Okay, and because you've got one version that's doing the normal thing, it's not showing the weird recessives you have. You've all got some. All right? But the likelihood that you would find a mate that has the exact same weird recessive alleles is pretty low. Unless you're pretty closely related, especially if your family's been doing this for a while. Okay? And so that's all. Inbreeding dramatically increases the likelihood of homozygosity. And that's a big deal with recessives because unless they're homozygous, you'll never see what they're doing. There are not very many dominant, nasty alleles out there simply because they get weeded out of the population really fast. Recessives can hang around for a really long time because they don't get selected against at a very high rate because they're hidden most of the time. But anyway, going back to these guys, so dominant recessive, pretty straightforward, right? I think most people actually don't understand recessive very well, and they think dominant should show up more. It only shows up, the only thing with dominant is that a heterozygote and a homozygote look exactly the same. You wouldn't be able to tell them apart. Now, that is actually usually not what happens. I find recessive alleles in most cases, I got an example of one that's not that, but recessive alleles are oftentimes something that's just full on broken. Okay, for example, albinos. Albinism is one of the easiest mutations to have happen. That's why there are albino versions of like everything with melanin. And a lot of times when I show these to people, people think this is an albino. It's not. Ball pythons have a lot of pigments that aren't melanin, and those still show up in an albino. This snake has leucism, which means that pigments are not attaching to its skin and scales. It makes all of them. They just don't attach. And so it affects the attachment in the skin and scales more than it affects the eyes. But anyway, I'm getting ahead of myself. Okay, so that's not the only thing that could happen. Because I could breed my black mouse and my white mouse, and neither of the alleles could be recessive. Which means they would have to both show up. Now, there's only two ways that they can both show up. One of them, I didn't finish what I was saying about albino, so I'll say that real quick. The thing with albino is just somewhere along the pathway to making melanin, it got broken, which is real easy to do. And so one of the alleles isn't making melanin. Now, if the other one still does, it makes melanin. It's only if both of them are broken that it won't make melanin at all. There's also a gene called MC1R, which converts red spectrum pheomelanin into brown-black eumelanin. If both copies of that are broken, you get this, which is pretty cool. And that's probably what most T-positive albinos are too. So you're a T-positive albino human, which is pretty snazzy. Anyway, but they can both show up, but there's only two ways this can happen. Option one, they both show up, but in different places. Option two, they both show up kind of, sort of. Okay, but not completely. Now, and I'll give you some examples of what this might look like. So let's say, hypothetically, that I bred this white snake with the wild type snake, the normal. Just sit here. I don't even need to put you away. I just need you to sit for a second, because I'll need you again in a moment. Okay? One thing that could have happened, well, I could have gotten all snakes that look like this one. Then what would that mean? This is dominant. I could get all snakes that look like this one. What would that mean? That was dominant. That's not what happened, though. That's not what happened. There's another thing that could happen. This is the only snake that is crazier looking to people than the blue-eyed leucistic when they see it. This could happen. Yeah, you're a nice one, aren't you? I love these. They're very cool. You can see. Like, you guys are reptile people. You've even maybe seen this before. I pulled it out. You're like, whoa. Because it's really cool. Okay, what would this be? This is piebaldism, which is a form of leucism, in which it's got patches that are seemingly relatively unaffected, and then it's got patches of white. If this was a heterozygote between that snake and that snake, that would be codominance. It's not what's happening, though. That's not how you make one of these. It'd be unbelievable if it was. Oh, man, I would be having the time of my life with these things. I already am. Can you go back in the back? Okay, you can sit on my shoulder. Okay, so that's what that would look like if it were codominance. But that's not what's happened there. And I still don't know what the heck a superdominant is. But if you breed that snake and that snake, what you get is this. Or an even lighter version of this. Okay? Which is a snake that isn't quite as dark as that one, nor is it as light as that one. It's halfway in between. And this isn't codominance. This is something called incomplete dominance. I didn't even know I had that. Is that from you, Brian? Wow, you are like a ninja. What else did you plant on me? Okay, I'll get that back here in a second. Once I employ you to put this snake back in that bag.
I'll hang on.
It's a wily sort. Okay. So this needs to clip on me somewhere. This is some fancy equipment. Is that where it was?
Yeah, that's good.
Is it? Okay. So what I noticed, all of a sudden it all clicked with me. I was like, because I was told this is dominant to the wild type, and then 2 copies super dominant, codominant. None of that checked out. I realized there is no allele for this. This isn't a thing. This is a heterozygote. There is an allele for this, and there's an allele for that. And if you get one of each, you get something halfway in between, and that's incomplete dominance. And I went, holy cow. And then I went to my second ever reptile friend that I ever had in my whole life, who did not grow up in Colorado. First one that didn't grow up in Colorado. Okay, so my second ever reptile friend, who happens to be one of the biggest breeders in the West, and then also is a geneticist. So I went to him and I was like, this isn't codominance, is it? This is incomplete dominance. And he said, yes. And I said, we got to tell them. Like, the entire, and he said, they'll never change. Well, I will tell you, at that, and I'm not taking full credit, but the timing was unbelievable. Because I had never, ever seen the words incomplete dominance used when talking about ball python genetics, ever. But this was in the early days of our YouTube channel. I actually did this as part of my PhD coursework. I created a 4-part series on ball python genetics. And they're some of the least viewed videos we've ever made. Because genetics is boring. But we put those out there. And I explained codominance and incomplete dominance and all these things. And suddenly, I mean, maybe 50,000 people watched it, which is actually a lot of people. And it's not everyone, not even close. But it's enough people so that probably somebody in almost every discussion is suddenly aware. And all of a sudden, I saw incomplete dominant being used all over the place. And codominance, more rarely, and just less and less and less and less and less did I see that used. And again, I don't know that that's what caused it, but it happened right then. And it's so exciting because apparently, we were never supposed to change. That was never supposed to happen. I want to go to okay, careful, you don't get over clicky. Because there is no going back. I clicked and it didn't do anything. Do I dare go forward again? Okay, not that one. This one? Okay, good. Okay. This, just for the record. There are very few examples of large-scale codominance that you can see, really. So basically, when you look at things, if the homozygote and the heterozygote look different, when you're talking about animal breeding, it's almost always incomplete dominance. And the reality is, almost everything is actually incomplete dominant. Even most of the things that are recessive, it's because it looks, the heterozygote looks very similar to the homozygote, but a lot of times they've got things that we often in the hobby call markers and stuff. You're looking for little clues that it's a heterozygote. And if you really know what you're looking for, most of the time you can pick out a heterozygote from a homozygote. So sometimes, it's usually some form of incomplete dominance, but it might be a lot more towards one side than the other. To be really true dominance, you would have to not be able to tell the difference. This is the best example of actual codominance I know of, which is blood types. Blood types are cool, and they actually demonstrate a really interesting thing too, which is that the same allele can be dominant and it can be recessive or incomplete dominant to different alleles, if that makes sense. If I had my whiteboard, I could make things make a little more sense. But you've probably heard of A, B, and O blood types. So I'll tell you, so there's 3 alleles going on. There's an A allele, a B allele, and an O allele. And they have to do with these binding sites, these antigen binding sites on the surface of the blood cell. There are 2 types of antigen binding sites. There's A and there's B. O simply isn't making any. Okay, which is why it's the universal donor. But it can't, it's not the universal acceptor because they got none. O, since it doesn't make any, if you have an O allele from one parent and an A from the other, well, you get the A's from the one parent and then you get nothing from the other one. So you have A binding sites, full on. B is the same way. If you got a B and O, well, the O's not making anything, but the B is still making the B's. So A and B are both dominant to O. That's why you have to be homozygous for O to have O blood type. If you have two A's, two B's, you actually have slightly more binding sites, but you still only have A or only have B. Okay, so the homozygote's uninteresting as always. It's only interesting when you get A and B. Now, if you had an A and a B and your binding sites were like some sort of a halfway between A and B, that would be what? That'd be incomplete dominance. Halfway between, incomplete. What you get is not that though. What you get is both A and B. You got full-on A's, you got full-on B's, you got nothing in between. What's that? That's codominance. That's what's really going on with blood type. So that is an example of real codominance. And I think in most cases, if you look at like the molecular level, almost everything expresses as codominant. But when you get to like the full organism level, most things express as incomplete dominant. It's kind of tricksy that way. But I want to talk to you guys about this. Because this is the most bananas thing. It's like once I realized that, I actually had the same realization about ball pythons and bearded dragons about 3 seconds apart, and I can't remember which one was first. Because in the same way, there are bearded dragons that have spiky backs. And there are bearded dragons that have much smoother backs. They call them leatherbacks. And then there are bearded dragons that have essentially no scales at all, called silkbacks. Okay, and what they said is that this leatherback allele is dominant to the spiky back allele. But if you breed two of them together, you get 25% super dominant, right? And it's codom. And that's why you get the silkbacks, the ones with the no. And I can't remember which one was the one that led me to the epiphany that there is no allele for leatherback and there is no allele for lesser ball python. And that's just the heterozygote, and it's halfway in between, having tiny little micro scales and full-size scales. You get these smooth scales. Holy cow! It's incomplete dominant. And one of those happened first, and I went, it has to be and so there's like a 3-second gap between when I learned this about bearded dragons and when I learned this about ball pythons. And I got so dang excited because it was real. My entire genetics education had been cartoon drawings. And I'll tell you something about those mice, by the way. Those same two mice aren't going to be incomplete dominant and codominant. It's showing me like the same two mice. It's giving me every possible outcome. No, only one of those is the real outcome. You got to give me a different gene if you want to show me something real. Like, for example, piebald that we talked about before and we stuffed in the bag. That's recessive. A little bit incomplete dominant because you can actually spot, if you really know what you're looking for, oftentimes you can notice that it's a heterozygote that carries the piebald allele, but for the most part, a het pied looks the same as a wild type. Okay, because wild type is dominant to piebald. Okay, at the same time, this cake, it is taped in there, so I guess you're just gonna have to trust me. This is a pinstripe. Pinstripe is a great narrowing of the pattern. For all intents and purposes, a heterozygous pinstripe, which is almost every pinstripe you've ever seen, looks the exact same as a homozygous pinstripe, one that has 2 copies, one from each parent. There may be like a tiny little difference because almost everything is really incomplete dominant, but it's like basic. I mean, you would have to be so trained to have any idea, and probably just the variation between pins is greater than the variation between a het and a homozygous pinstripe. So it'd be really difficult to spot. That's real dominance, okay? This is another thing, and I did manage to track one down. This little guy is a banana ball python, which is far and away the weirdest inheritance pattern I have ever heard of ever in my whole wide life. It's so weird. It's so weird, and it's weirder than people even know it was. Okay? Because most people don't understand genetics well enough to even know why. Like, they knew it was weird, but the more you knew about genetics, the less sense this made. Okay, so I'll tell you what happened. This is the story. Brian might know this story better than I do, but this is my understanding of how this all played out. So the first one of these was found probably in Africa. And obviously, like, this snake is way different than the normal ball python. And you go, that's cool. Those Americans are going to want that. Okay? And so they sent that over. And the first thing you do when you get a dinker like this is you go, okay, well, is it heritable? Because it could have just been something weird about like the incubation temperatures or whatever. And that's fine. It's still a cool snake, but its babies aren't going to look like that. And so like the value of it as a breeder goes through the floor. And so the first thing you do is like, oh, I'm going to breed this and see how it's inherited. Okay, now this is something you always do. And say I breed it to a wild type. If all the babies are wild type, does that mean for sure that this isn't heritable? What might be the case? Might be recessive, right? And so then I would probably breed this one to one of the babies, which is inbreeding. It is. It's inbreeding. Because I'm trying to increase the likelihood of homozygosity. Okay? If it's recessive, I want to get a homozygote so I can see it. If I can get even one, I'm like, okay, that shows that it's heritable. And now I know it's recessive. And so they could all come out not looking like this. But half of them came out looking like this and half like that. Which is very much the indication that it's some form of dominant. Okay? And there was, the first one that we found was a female. And when she bred, like we got half that looked like this, half that looked like that. There was nothing weird about it. It was half the males, half the females looked like this. Half the males, half the females looked like that. Nothing weird. Everything's normal. All well and good. Then, the males hit breeding age at about a year. Females like 3 years. So the males hit breeding age first. And when the males started to breed, they had half of their babies that looked like this and half that looked like that. Nothing weird, except for the fact that all of the females looked like this and all of the males looked like that. Which could happen by chance, but the more babies you have, the less likely that becomes. And it was all of them for a long time. After a few years, and they've been breeding these males for like 3 years by this point, and it's all the females like this, all the males like that. Even though the male looked like this that produced them. Okay? And so you're like, what the heck? Right? The males that look like that, they didn't produce any babies like this. So it's just these males that look like this, only their daughters look like this, all their sons look like that. Then the females hit breeding age. Started breeding them, nothing weird. 50%, half the males look like this, half the males look like that, half the females look like this, half the females look like that. Nothing weird. Eventually, after a few years of breeding them, one of these males produced one son that looked like this. Which is cool. Broke the trend a little. But when you're like 50-1, that's still like, these are some really strange odds. Right? Like you flip a quarter a lot of times, you don't get that very often. Can happen. Very unlikely. That male, a year later, hits breeding size. They breed him. And this time around, all of his sons look like this, and all of his daughters look like that. And if you haven't been paying attention, that's the opposite. Today, if you go to, so bananas were very, very valuable because any snake that you can get looking like this with one single allele change from just one parent, and it goes from that to this, like that's probably, I don't know if there's a single gene more crazy than that. So it's already like bonkers. But we got this crazy pattern, and the males breed more often and they breed sooner. And you want to produce as many as you can. And so virtually all of them are the descendants of that early male that was spreading it to all of his male offspring. They call him a male maker. All of the previous males that only pass it on to their female offspring, they call those female makers. Okay? And I will tell you, I know about some interesting things with sex determination, or obviously this is somehow related to sex determination. But this pattern, you can memorize this pattern. That was the thing. Like when I first started talking about what was going on here, people were like, well, we know what's going on here. Sometimes all the males get it, and sometimes all the females get it. What's so weird? I'm like, but why though? Why would that be? And I will tell you, I know about some weird things that are related to sex determination. For example, can everybody see what dinosaur that is? Is there anybody who can't see what's going on here? Oh boy, oh boy, oh boy. This is a good group. This is a good group. Well, I will tell you, I have never once in all the classes I've taught, I have never had a single class where I didn't have at least one male student who couldn't see this. But I've only ever had 2 students with XX chromosomes that couldn't see it. And I can tell you some crazy stuff about your family. I seemed like a wizard for a while. Because here's the thing. Humans have XY sex determination. Okay? The gene for being able to differentiate between red and green is on the X chromosome. Females have 2, and it's recessive. Males have 1, because we're XY. We got 1 X chromosome. If that X chromosome has a broken version of this gene, you can't tell the difference, and it's pretty easy to get 1 copy of it. The likelihood of getting 2 copies in the same person, way, way, way lower. And so it doesn't happen very often in females. This is a pattern I've seen. Way more often in what's called the heterogametic sex, the one with 2 different chromosomes in the sex-determining chromosomes. Cool? Anyone with 2 X chromosomes, by the way, who can't see this, I know your dad was red-green colorblind. I know it. There's also a decent chance, not for sure, but your maternal grandfather may also have been red-green colorblind. That's not a guarantee. But you also have, if you've got multiple brothers, probably some but not all of them are red-green colorblind. Same deal with sisters, actually. Probably 50-50. Okay. See, I know some things. This is why when the why is so not obvious, I'm like, but why though? Right? I know stuff. I know stuff about this. This makes sense to me. That's not what's going on here. Not at all. This is a little bit related. Yeah. If you breed a black cat with an orange cat, do you know what you get? Now, sometimes you get a black cat. Sometimes you get an orange cat, if they're male. Depending on which one of these is you'll get them the same color as their mom, if they're male. However, if they're female, got to make sure not to overdo it. They look like this. And then if they're also piebald, so if they have one black parent, one orange parent, and also piebaldism, which you guys know about piebaldism now, right? It looks like that. Okay. I know stuff about cats. All right, and this is a great example of codominance. Except that's not what's going on. But that is what it would look like. Okay, because here's the thing. You can't have two X chromosomes. It'll kill you. You get what's called a dosage effect. So both chromosomes, if they're making all the stuff, you'd be making twice as much of everything on that X chromosome as males do. And that's too much to live with. All right, if you're familiar with trisomies, the most commonly known one is trisomy 21, which would be Down syndrome. There's no weird mutations or anything going on there. Everything with Down syndrome is just that you've got 3 of chromosome 21 instead of 2. And so you're making 1.5 times as much of the protein products as somebody with only 2, and there's some clear phenotypic differences. Trisomy 21 is a great trisomy to have. It's one of the few that you can survive. It'll usually kill you if you've got 3 of a chromosome. Well, it'll kill you if you got 2 X chromosomes. It's too many. Too many. But I've noticed a number of you have 2 X chromosomes and are remarkably not dead. And the reason for that is because in every cell in your body, you have shut down one or the other X chromosome. Okay, in most of you, I can't really tell the difference. However, if you had alleles for being black or orange on your X chromosomes, and you had one of each, I would have a very good idea which one you shut down where. And interestingly, in humans, there is something sort of similar. There's a gene for sweatiness on the X chromosome. And females are often, they'll have patches of real sweaty skin. These are only the heterozygotes. Patches of sweaty skin, patches of not sweaty skin. This is called X inactivation. That's weird. It's not what's going on here. And this pattern, like obviously the weird thing is with the males, right? The males are doing the weird thing. Well, I'll tell you something that made this worse. It's already bad, right? It doesn't fit anywhere close to any pattern I've ever heard of in inheritance. But snakes and most lizards are, generally speaking, ZW sex determination, not XY. Okay, what that means, the only difference, this is the whole difference, it's the males that have it's the females that have 2 different chromosomes instead of the males. This is also really common in birds. Okay, ZW sex determination. So the females are the heterogametic sex, not the males. Well, that would make you think that the weird stuff should be going on with the females. Right, but it's not. The weird thing is going on with the males. What the heck? What the heck is going on? So this would come up in just like forums I was part of on Facebook, like, I don't know, 6 times a week. People are like, what the heck's going on with banana? I don't know. Nobody knew. Nobody's just like, I have no idea. I would always ask the same question. Does anybody know how sex is determined in ball pythons? Because nothing made sense. And then one day, somebody posted that they posted a paper. It wasn't even about ball pythons, but it was about pythons and boas. And it found that pythons and boas are each independently XY sex determination. Okay? And all of a sudden, upon learning that, something clicked in my head and I went, oh. And it all made sense to me. And I wrote it out in some Facebook group somewhere. I'm like, you know the biggest mystery in all of ball python genetics? Here it is. And so I just did this. And then I was like, what are you doing? This is the biggest mystery in all of ball python genetics. You should probably do something to show that you figured this out. And so it was like our 4th video ever on Clint's Reptiles. I just throw a shirt on. I don't think I'm even wearing dress pants. My shirt's not even tucked in. I filmed it. Usually, well, our first video took us 3.5 months to produce. The next one, a month. This is like 1 day later. I'm like, this is up. It's the lowest quality video we've ever made, but I'm just like, go! And so I just I explained it, so at least there's some record that I figured it out. And here's what's going on. So this allele is on the sex-determining chromosomes. You know that. That's been obvious from the beginning. This is the thing that's really different from anything I've ever seen before, like the color blindness thing. It's most similar to the color blindness thing. The thing about this is it's not just on the X chromosome. It can also be on the Y chromosome. And the Y chromosome in ball pythons is large enough so that something that your chromosomes from your parents that you usually have that you have that are not way different from each other normally do, which is called crossing over, where they swap little sections of themselves. It's big enough so that they can do crossing over and switch sections of themselves. Okay? So the first one we had come in was a female. She had it on an X chromosome because she only has X chromosomes. We bred her. She passes on her X chromosomes to her male offspring and her female offspring, but she only passes one or the other. So half of them get the one with banana and half of them get the one without banana. And it has nothing to do with their sex because the female, being XY, not ZW like most snakes, being XY, the female doesn't have anything to do with sex determination. Her sons definitely have it on their X chromosome because they got it from their mom. And they got their X chromosome from their mom. And so the sons all have it. Well, half of them have it. But when they breed, they pass their X chromosomes on to their future daughters. If they pass their Y chromosome on, that's called a son. Okay? And it's not on the Y, it's on the X. So they pass it on to all their daughters, none of their sons. But because in ball pythons, they still do crossing over, they swapped it. They swapped that section of the chromosome onto the Y one time. One time. And after that happened, that male now passes it on with his Ys, which he only passes on to his sons and never his daughters. And so that's how we wound up. Male makers simply have it on their Y chromosome. Female makers have it on their X chromosome. I've never heard of anything else like this because like in humans, which are usually the things that we talk about with X linkage and things like that, the Y chromosome is really tiny. And I don't know if there's any crossing over that happens and with the X chromosome. And so you'd never see anything like this. But it was completely different. And I'll take that to my last thing that I want to show you guys, which is this. This is the last thing that confused me. And everyone else. So after getting to the bottom of what in the world is going on with banana ball pythons, also coral glow. If you've ever heard of coral glow, it's probably the same thing. If it's not, it's a almost identical mutation to banana, and the same thing goes on. So same. This, by the way, is a banana ball python, except for where it's not. We call this paradox. It's not heritable. Remember what we said about breeding it and trying to figure it out? You breed that snake, they come out like normal bananas. Like you don't get any of these. I do now have one, not with banana. It's a blue-eyed leucistic actually. But this happens from time to time. Have you ever produced one? How did you feel? So good. Okay, so that's really weird. It's really weird. And I can't go back, so soak this one in. I would have probably gone back between these, but this next one bothers me even more than this one. I do want you to notice, and this isn't always the case, but there's a split right down the head, which is really cool. You're going to see that on the next one too. But you see, like, there's patches here that are not banana. This one, this one's albino. except for where it's not. This one really upsets me. Because what is happening? Right? The most common explanation I've had for paradox is a somatic mutation. The somatic just means all the cells that aren't sex cells. Okay, so while this snake was developing, split down the head. Split down the head means it had to have happened very early in development, because all that stuff starts forming really early. In early development, at some point, it had a mutation happen in one of the cells. So you start out, just for the record, as one cell. Very early in your development, you were just one cell big. And then that cell divided into two. And then those two divided into 4, and then 8, and then 16, 32. Then they formed a little ball. And then all of a sudden, it caved in on one side and popped out the other side. And the part where it caved in first, that eventually became your anus. And where it came out the other side eventually became your mouth, which is just the far side of your anus. And that's what happened. And so because you were so few cells, each of those cells was going to become a lot of cells in you. Okay, and so if early on you get a mutation in one of those cells, well, it actually affects a lot of the cells in your body. And so the explanation for this was, well, they just had a somatic mutation. Well, the thing is, this python has 2 broken copies of the genes for making melanin. And the likelihood that the mutation it's going to have is going to fix that is so low. It's so unbelievable. Just infinite. It would never, like, if this has ever happened, it's happened like one time. We undid albinism. These happen all the time. I asked one breeder, I'm like, have you ever made one? He's like, yep. Okay, so this happens a lot. That makes no sense. And sometimes, as I think might have been the case with that last one, maybe this one as well, like this snake has multiple things going on. This isn't just albino. This is like albino and black pastel or something like that. This looks like normal wild type. So it's undone a couple of mutations. And so I've been studying this for a while. I haven't made a video on this subject. And if any of you guys are breeders that have had experience making paradoxes, whenever I meet somebody who's produced a paradox, I always ask the same question, which is, I want to know what the parents are. Because I suspect, and so far there have been 0 exceptions to this rule, that no one has ever produced one of these by breeding 2 albinos. To get this snake, the parents had to be able to produce this snake and this snake. Now, I told you before that I have a paradox now. It's a paradox blue-eyed leucistic. So it looks like this snake, except for where it doesn't. And my snake, though a female, her name is Dwight. Some of you may be familiar with the fact that Dwight has the strength of a grown man and a little baby. Can any of you explain that to me? What do you remember? Do you remember? Yes. Okay, that's all right. Does anybody remember? What do you remember? He absorbed his twin. Okay. The only explanation that I've been able to find that makes sense of this is that these were fraternal twins in the egg early in development that fused together and became one snake. That's why you will never find either phenotype that the parents couldn't produce. Both are there. If you find an exception to that, please tell me, because that will be something different. But I haven't found any exceptions to this rule. This is how I'm testing my hypothesis. Okay? And so, and just for the record, that last one we saw being a banana, I think if you tested the different patches of skin, you would find they're not even the same sex. So there's something exciting for you, right? This is the opposite of identical twins, for the record. Identical twins are one zygote that becomes two. This is two zygotes that became one. And anyway, that is the last major mystery I know to exist in ball python genetics. But if you know of more, I do like thinking about these things. So what else would you guys like to know?
Thank you guys for watching. I hope you enjoyed it as much as I watched Clint giving that talk. Always a pleasure to hear the man speak. Stay tuned for this weekend. And again, join us on the Palmstreet Live tomorrow for some fun driving antics. Y'all take care of yourselves. Take care of each other. See you on the next video. Aloha.